Go. Write an equation of the line that passes through the given point and has the given slope. So let's see, I have an x, I have a y, I have an m. What's my equation? Y equals mx plus b, y equals mx plus b. Awesome. So let's plug in what I know. Y is 1, m is 2, and remember this is 2 times my x is 5, plus b. Now we solve it. 1 equals 2 times 5 is 10, plus b. Subtract 10 from both sides, and b equals negative 9. I have a b, I have an m. Plug them back into y equals mx plus b, y equals mx plus b, y equals 2x minus 9. There you have it. All right, let's try another one. Write an equation of the line that passes through the given points. Start, like always, with y equals mx plus b, y equals mx plus b. All right, so now let's see what I have. Ooh, I have an x, I have a y, I have another x, and another y. No slope. I can use my slope formula. y2, 9, minus y1, 2. x2, 4, over x1, 3. So 9 minus 2 is 7. 4 minus 3 is 1, so our slope is 7. Now I can plug it back in. Does it matter which y I use? It does not. You can use either y you want. I usually look at these and see which numbers are going to be better for me, so I use smaller numbers. So my y I'm going to use is 2. So 2 equals 7 is my slope right there. X is 3. Plus b. Now the only thing I can't do over here is I can't use the y from this point and the x from the other point. If I'm using this point, I got to use both the x and y from this point. So solve it. 2 equals 7 times 3 is 21 plus b. Subtract 21. So negative 19 equals b. So plug it into my formula. Y equals mx plus b. Y equals mx. Just kidding. It's in your head, right? Y equals 7x minus 19. All right, let's try another one. Oh, this was we have a graph. Great. You know what I love about graphs? It gives us points. Like this point is 1, 2, 3, 4, 5, 6. And 1, 2, 3. And this point here is 1, 0. And if you remember, it's wherever the wherever the cross y-axis is my intercept. Oh, that's a nasty one. That looks like a decimal or a fraction because it's not 0 and it's not 1, which would be nice, right? So we need a y, we need an m, we need an x, and we need a b. So let's see our y. I'm going to use this point because look at that, 0 is awesome. So my y is 0. My m, I could use the formula, right? Or I can just look on my graph. What's my change in y? I go up 3. What's my change in x? 1, 2, 3, 4, 5. Over 5. So my slope is 3/5. So 3/5 times what's x? X is 1 plus b. Now I solve it. 0 equals 3/5 times 1. That's a hard one. I don't know. Oh, 3/5 plus b. Subtract 3/5 from both sides. I know you guys love them fractions. 0 minus 3/5. Oh no, calculator. Oh, it's negative 3/5. Okay, then plug it into y equals mx plus b. Y equals m. What's my m? I found my m was 3/5. X plus b. What's my b? Negative 3 over 5. Now I think we've talked about this, but remember, adding negative 3/5 and subtracting a positive 3/5 is the same thing. Okay, let's try another one. Oh, application. Let's look at this application. Mr. Sullivan planted a Buckeye tree in honor of them winning the national championship. Go Buckeyes, Ohio State. After 4 years, it had grown to be 12 feet tall. After 8 years, it had grown to be 18 feet tall. Write an equation of a line. So let's get some information out of this. 4 years and 12 feet, those go together like a coordinate. 4, 12, there's a point. How about after 8 years, 18 feet? 8 years, 18 feet. Okay? So now I can do everything I need. Can I find my slope? Sure. y2 minus y1. 18 minus 12. x2 minus x1. 8 minus 4. So that's 6 over 4, which reduces to 3 halves. So we know my m is 3/2. Plug it into our equation. What's that equation again, Mr. Kelly? Y equals mx plus b, y equals mx plus b. Either point we can use, I'm going to use the first one because it looks like it'd be smaller number. So y is 12. Our m is 3/2. Our x is 4 plus b. I'm going to come into this part b. Sorry about that. 3/2 times 4, well, 2 goes into 4 twice. 3 times 2 is 6, so I have 6 plus b. Subtract 6 from both sides, and 6 equals b. So my equation is y equals 3/2 x plus 6. That's part A. Now, the reason equations are great to have, we can use them to figure out other things. For example, how tall was a tree when Mr. Sullivan planted it? Well, when Mr. Sullivan planted it, x was 0. You could plug 0 times 3/2, that's 0. 0 plus 6, that's 6. So it was 6 feet tall. You could find out how tall it's going to be at any length in time, okay?